Hello friends, welcome to MathAlcoholic. So in this video, I will be discussing question number 15 of the miscellaneous exercise of relations and functions. So without any further delay, let's start. They said that let A is equal to, the set A is minus 1, 0, 1 and 2, and the set B is consisting of elements minus 4, minus 2, 0 and 2. And there are two functions f and g that is defined from domain A to the codomain of set B. And those functions are defined by f of x is equal to x square minus x for x belongs to A, and g of x is equal to 2 modulus of x minus 1 by 2 minus 1 for x belongs to A. Now we need to see whether f and g are equal or not. From a very primitive understanding, anybody would conclude that f and g are not equal because they are simply not seeing this to be equal. But let me say that the equality of functions very much depends on which set of domains and codomains they are defined on. That is what we are going to explore here. So let's start by the given information. It is given that A is equal to minus 1, 0, 1, 2. B is equal to minus 4, minus 2, 0, 2. Alright. Now also it is given, we are defining the functions. We are not defining actually, we are just giving the functions that are being defined here. F from A to B is defined by f of x is equal to x square minus x, where x belongs to A, and g is from A to B is defined as by g of x is equal to 2 into x minus 1 by 2 minus 1 for x belongs to A. Now there are only 4 elements and 4 elements in the sets A and B respectively. So we are checking the inputs and outputs of f and g. Okay, this we are going to check. How? F of minus 1. What is f of minus 1? By definition x square minus x, so it is going to be minus 1 whole square. Minus of minus 1. Minus 1 whole square is 1. 1 plus 1, you are getting it 2. What is f of 0? F of 0 is 0 square minus 0, that is equal to 0. F of 1 is 1 square minus 1, that is equal to 0. And again, f of 2 is equal to 2 square minus 2, that is 4 minus 2, that is equal to 2. Now, you can clearly see that this 2, 0 and 2, these elements belong to this set B. And I have taken all the elements from this domain to explore it. Now again we will be checking the function g in the same way. G of minus 1, what we get by definition, since g of x is 2 into x minus half minus 1, so it is 2 into minus half minus 1 by 2 minus 1, that is equal to minus half minus 1 by 2 gives you minus 3 by 2. If you take modulus, it will be 2 into 3 by 2 minus 1, and that will be giving you 2. G of 0 will be 2 into 0 minus half minus 1, that will be resulting you a good 1 minus 1, and that will be equal to 0. G of 1 is equal to 2 into 1 minus 1 by 2 minus 1, that is equal to 1 minus 1, and that is equal to 0. And g of 2 is equal to 2 into 2 minus half minus 1, that is equal to 3 minus 1, that is equal to 2. 3 by 2 into 2 is 3, 3 minus 1, that is equal to 2. Now see, interestingly, f of minus 1 is 2 and g of minus 1 is also 2. In the same way, all the domains that we input in both f and g corresponding to this set A to B, same thing, we are getting f of A is equal to g of A, okay, for all these domains and range. Therefore, just on a concluding note, f of minus 1 is equal to g of minus 1 is equal to 2, f of 0 is equal to g of 0 is equal to 0, f of 1 is equal to g of 1, we can see that is equal to 0 also, and f of 2 is equal to g of 2 is equal to 2. Alright, so therefore we can say that f of A is equal to g of A for all A belongs to the set A. Now since in the domain these both functions execute similar type of results, similar output, hence these two functions are equal. Okay, hence we can conclude that f and g are equal. Okay, now we need to note one thing, that two functions does not look like the same here. It may not look like the same, but depending on the domains and codomains, it can be same. It is being clarified in this point. Okay, so don't ever think that two functions which don't look to be the same are not same. This is a clear-cut example of it. I hope you have no doubt, friends. If you have any kind of doubt, please feel free to use the comment section. I'll be meeting you in the next video where I'll be discussing question number 16. Thank you very much for watching this video.